Hi everyone, my name is Emily Wade, and this is a group project for mine and Ashley's 300 class, which is forecasting at Liberty University. And this is part 2 of our video, so if you haven't checked out part 1 yet, I strongly suggest you do that before watching this one. But in this video, I'm going to discuss the results and the code and how we approached this novel problem. So, how are your hoops? So, we were to create a dynamic ARIMA model, and what we picked, we decided to do basketball and forecasting the total number of points for a selected player in the NBA for the 2016-2017 season. So this upcoming season. And the way that we did that was we took the two time series components of the total number of minutes played for the past 6 seasons and the total number of points made for the past 6 seasons, and we took those two and we combined them to make our dynamic ARIMA model in order to forecast the total number of points for the 2016-2017 season. So here are our players that we selected: Carmelo Anthony, Steph Curry, LeBron James, and Russell Westbrook, which there's some pretty big names in the NBA right now. So it would be really interesting to look at them and see what they're going to do in the future. So in order to make sure that our model is correct, what we first did, we based our model off of forecasting for the 2015-2016 season, in which we already had our data on. So I'll go through the example with LeBron. Here you see our forecast, and this is our line of code that we used. We're calling in the test points data, which is the data with just minus the 2015-2016 season. And then we're making the test minutes data, which is all the minutes minus the 2015-2016 season. And we called those in. This is our dynamic ARIMA code right here. And then we decided to go with this type of ARIMA because it's what we did some trial and error. As you can see, the D, which is the diffing, it's 0. So we played around with our P's and our Q's, and we decided that this was the best model for LeBron James, and it gave us the closest forecast to what he actually scored. So we forecasted that he would score 1,962 points, and he scored actually 1,920, which is a really good forecast for what we're doing. And so now I'll just take you in to R and show you the other players that we did. Here is Steph Curry's test, and you can see that the model that worked best for him was a 1-1-1. And we did a lot of trial and error, just researching and just trying to figure out which numbers to put in these slots. And it took a while for us to figure them out, but the numbers that are in there now for this model is what gave us the best results. And so Carmelo Anthony, here's his was a 1-1-0. And then I've shown you LeBron James, which is a 1-0-1. And then we did find for Russell Westbrook that a 0-0-0 was the best model, which is basically just an average. But we found that that was the best fit. None of the other ones were really lining up, and it's probably because of the way his plot looked. And so as you can see right here, this is his historical data for the points that he made, and he's been pretty inconsistent. So it's been a lot of up and downs. And you can see right here, it was a huge peak down and then a huge peak up. So we thought that instead of having another huge peak down, that we would make it a flat average. And it worked. That was the best, and that gave us the best estimate for the actual amount of points that he did score. So I'll take you back to our PowerPoint. And then implementing the model into the code to actually forecast for this season. We kept the model, but we switched the data, and we included the 2015-2016 data, and then we forecasted for we did it for 2 years just to see what would happen, but we really just focused on what would happen next year. And so as you can see right here, this is our LeBron James model, and he is forecasted to score 1,953 points next season, this coming season. So hopefully, we're really excited to see how these actually line up. But I'll take you back over to R, and I'll show you the code that we used for this, which is the same model. And as you can see, here's our code. We import the data sets, and then we make the data set a time series. It's one thing that we struggled with in the beginning. We had to research how to do this because we knew it was time series data, but just importing it from this CSV file, R did not. So we had to switch it over to a time series. So that's what we're doing right here. Then we plot the data, and I'll show you the plots of those just so we can check them out. And this gave us a really nice visual representation of what was going on with the points to try to figure out the model that would be best for the selected player. And then we then went into the models. So for Steph Curry, if we can play his code, we forecast that he will score 2,547 points, which is a really good forecast because he's been doing so well. And as you can see, it increases for the next season. So I think that this is a very accurate representation of what he has been doing in the past seasons, because he's really just blown up the NBA world right now, and he's really making a lot of threes. So if everything just stays on track, then this should be a pretty accurate forecast. And then for Carmelo Anthony, this one's a really interesting one, and he's only forecasted to make 811 points. Now you can see right here, he's had like a big drop off, and he improved a little bit last season, but just based on what he's been doing, he's going to make a lot lower amount of points. And this really lines up to where he is right now in the season. He's not doing great, and so this is a really accurate representation of how he was started off strong, but now in recent seasons he's really just like tapered off. And so if the forecast represents that very well. And so if you look at LeBron James, this is the one I showed you before, we forecast him. He's been pretty up and down, but as of last year he was pretty steady, and we forecast him to make about 1,952 points. And then he brings it down a little bit, which you can see it probably the model picked up this little downward trend that he was having and forecasted that he would have less points for the 2017-2018 season. And then our last one, Russell Westbrook. This was the one where we decided to go with just the average because he had this huge dip, and so to account for that, we just did the average because he seemed, other than that, he seemed to be very consistent in what he was doing. So we averaged him out, and we decided that he would probably score around 1,670 points. And of course, these models don't take into account the possibilities for a player getting hurt or injured, but that's just something that you really can't model. And based off of the models that we have and the testing that we did on the data in order to get the models, the testing lined up very nicely, and so we believe that these are some really good, accurate models that forecast the total number of points that these players are going to score. Now I want to show you a little bit that we did, a little playing around we did with in a neural network. We wanted to originally go in this direction because it's something new, but like we have never done it before, so we were very skeptical of the results that we got. And right here, this is our neural network that we came up for Steph Curry, and going through it, we made our test data, we made our targets, we made our inputs, and then we had issues with the initialization, figuring out what to put there, and then actually putting our last values. So we didn't, once we got this, we did get a pretty not an off-the-wall answer. You can see the answer was 1,217 points, but that really wasn't up to what he was doing at this time for the 2015-2016 season. So we decided to go in a different direction, and that's when we started testing the data in R and running all of these different test data models, and we found that our R code in our R ARIMA model was much better and much more accurate than what we found in our neural network MATLAB. So we went ahead and we committed to using R to forecast our values. And then right here I just have our results, but I've already been through them. But all in all, we think that we came up with a really good dynamic ARIMA model to encompass these players and what they're doing right now. And we really look forward to seeing how well our predictions line up with what they're actually going to do at the end of the season. So thanks for watching, and check back with us soon for more videos.